In this problem, we are asked to write balanced equations of various kinds for the reaction between aqueous solutions of calcium hydroxide and nitric acid. Calcium hydroxide being a base and nitric acid obviously an acid. This will be an acid-base reaction. And we need to be able to write the molecular, the total ionic, and the net ionic equations for this reaction. The molecular equation is perhaps the simplest, and it consists simply of the formulas for the reactants and the products, and some indication of their state. So let's start with the molecular equation. So that will be calcium hydroxide. From the name, we deduce that the formula is CaOH taken twice, and this will be an aqueous solution. Nitric acid, from the list of acids that we needed to learn, is HNO3, an aqueous solution. And since it's an acid-base reaction, we will end up with a salt and water. Now in this case, calcium ion will form the salt Ca, NO3 taken twice, an aqueous solution. This is calcium nitrate, and the other product will be water. This is the skeletal equation for the neutralization reaction between this base and this acid. Now it isn't balanced yet, so we do need to balance it. Since there are two nitrates in the calcium nitrate, we're going to have to start with 2 nitric acids, and that will in turn produce 2 protons, which will combine with the 2 hydroxide ions to make 2 water molecules. So this is the molecular equation for the neutralization reaction. The total ionic equation shows the ions as they will exist in solution when these electrolyte materials are dissolved. It shows all the ions that form. Calcium hydroxide will dissolve in water to form calcium ions plus 2 hydroxide ions for each calcium. Nitric acid is a strong acid, so we'll have 2H plus aqueous plus 2 NO3 minus, that's the nitrate ion, an aqueous solution. Calcium nitrate among the products is a strong electrolyte. It would be calcium 2 plus aqueous plus 2 nitrate ions aqueous plus of course the 2 water molecules. This is the total ionic equation, and we can compare that with the molecular equation. We start with the molecular equation to see the formulas of the reactants and the products. We allow each formula to dissociate as it would in water to form the ions that appear in the total ionic equation. Now the last thing we need to do is to write the net ionic equation. The net ionic equation just has in it the ions that undergo reaction and whatever the product is. That is to say, we remove the spectator ions. The spectator ion is the same on both sides. So to get from the total ionic equation to the net ionic equation, we look for the things that are the same on both sides. Calcium ion, calcium ion. 2 nitrates, 2 nitrates. What's left after we have done that is the net ionic equation, which in this case you can see is 2OH minus aqueous plus 2H plus aqueous going to 2H2O. And of course we can simplify that one step and divide through by 2 to get it as simple as possible. We could say it's OH minus aqueous plus H plus aqueous going to H2O liquid. So this will be the net ionic equation. And in fact, the net ionic equation for any neutralization reaction will look just like this, because the formation of the salt, calcium nitrate in this case, is only representing the formation of the ions of the salt. As long as it's soluble in aqueous solution, calcium nitrate, all ionic nitrate things, nitrate compounds are soluble. So we remove those spectator ions and we get the net ionic equation.